Good afternoon, viewers and listeners. Welcome once again to Salida TeleRadyo of La Filipina National High School. I am your teacher host, Teacher Joseph Persuelo, and today you will learn many things about solving corresponding parts of congruent triangles. Lesson in Mathematics 8, Quarter 3, Module 2A. Are you all ready? Let's give the floor to our teacher broadcaster, Teacher Jason P. Flor de Alta.
Good morning, viewers and listeners. Once again, I am Sir Jason Flor de Alta, your teacher broadcaster for today for Mathematics 8. Our lesson for this day is all about solving corresponding parts of congruent triangles. But before that, let us have first our objective so that we will be guided throughout our discussion. At the end of the lesson, the students are expected to find the unknown sides or angles of the right triangles using the LL, LA, HL, and HA congruence theorem. Before we start, let us review your prior knowledge about right triangles. Can you recall the parts of the right triangle? Alright, these are the parts of a right triangle. We have here the opposite side or leg, the adjacent side or another leg, and also the hypotenuse. Hypotenuse is the side opposite the right angle in a right triangle. It is also the longest side of a right triangle. Next is the opposite side. The opposite side is the side opposite the angle of interest in a right triangle. Next is the adjacent side. The adjacent side is the side next to the angle of interest in a right triangle. The legs of the right triangle are the two sides that intersect or form the right angle. Since we are now refreshed about right triangles, we can now proceed to our lesson. And our lesson once again is all about solving corresponding parts of congruent triangles. But we will just focus particularly on right triangles. So these are the additional congruence theorems on triangles. We have here first the LL or the leg-leg theorem. The LL theorem states that if the legs of one right triangle are congruent to the legs of another right triangle, then the two triangles are congruent. We have here the illustration for the LL theorem. So as you can see, there are two right triangles on the illustration. So the two right triangles are congruent on both of their legs. The next theorem is the LA theorem or the leg angle theorem. LA theorem states that if the leg and an acute angle of one right triangle are both congruent to the corresponding leg and acute angle of another right triangle, then the triangles are congruent. So here is the illustration for the LA theorem. So as you can see, we have again the two right triangles. Indicated there are the leg and the acute angle. Next is the HL theorem or the hypotenuse leg theorem. Hypotenuse leg theorem states that if the hypotenuse and leg of one right triangle are congruent to the corresponding hypotenuse and leg of another right triangle, then the two triangles are congruent. Here is the illustration for the HL theorem. So as you can see, the two legs of the two right triangles are congruent, and also the hypotenuse of the two right triangles are also congruent. The last one is the HA theorem or the hypotenuse angle theorem. Hypotenuse angle theorem states that if the hypotenuse and an acute angle of one right triangle are congruent to the hypotenuse and an acute angle of another right triangle, then the two triangles are congruent. So this is the illustration for the HA theorem. So as you can see, again, two right triangles indicated there are their corresponding acute angles. So they have the same, or congruent acute angles, and also their hypotenuse are also congruent. So have you understood the lesson? If yes, we will now proceed to our example. Example number 1. Find the values of x and the measure of angle G. So as you can see in the illustration, we have here the right triangle LMN and right triangle GFH. It is indicated in the figure that the corresponding legs of the two right triangles are congruent, and also the corresponding acute angle of the two right triangles are also congruent. So, by the LA theorem or the leg acute angle theorem, the two triangles are congruent. With that, the acute angle given on triangle MNL is equal to the acute angle given on FGH. Example, find the values of x and the measure of angle G. So as you can see in the figure, we have triangle MNL and triangle FGH. So it is indicated in the figure that the legs of the two right triangles are congruent, and also the corresponding acute angles of the two right triangles are also congruent. So they are congruent in their legs and also their acute angle. Therefore, by LA or leg acute angle theorem, the two triangles are congruent. With that, the acute angle given on triangle MNL is equal to the acute angle given on triangle FGH. So, given the measure of angle N is equal to 80 degrees. And by the LA theorem, side LM is equal to side FH as seen in the markings. And also, the measure of angle G is equal to 2x. So, we must solve for x and also the measure of angle G. Solution. 2x equals 80. Divide both sides by 2, so the value for x is equal to 40. And then, since x equals 40 and the measure of angle G equals 2x, so the measure of angle G is equal to 2x. Substitute the value for x, which is 40, so we now have a measure of angle G equals 2 times quantity 40. Therefore, the measure of angle G is equal to 80 degrees. Did you understand our example? Now, let's proceed to our assessment. Find the values of x and solve for the length of the hypotenuse. So we have here our figures of two right triangles. I will give you 1 minute to answer the problem. Your time starts now. Alright, time is up. Let us check your answers. Based on the figure, we can conclude that it is HL theorem or the hypotenuse leg theorem. The two right triangles are congruent. With that, the hypotenuse of the two right triangles are also congruent. Given that the two triangles are congruent, then in solving for x, 2x plus 2 is equal to 5x minus 19. 2x minus 5x is equal to negative 19 minus 2. 2x minus 5x is equal to negative 3x. And negative 19 minus 2 is equal to negative 21. So, we now have negative 3x equals negative 21. Divide the whole equation by negative 3. So, we will now have the value of x, which is negative 21 over negative 3 or 7. So, the value of x is equal to 7. We will now solve for the hypotenuse of the first triangle. The hypotenuse of the first triangle is equal to 2x plus 2. The value of x is equal to 7 based on the solution that we have made earlier. So, substitute the value of x to the equation. So, it will become 2 times quantity 7 plus 2. 2 times 7 is equal to 14. 14 plus 2 is equal to 16. Therefore, the hypotenuse of the first right triangle is equal to 16. Solving the hypotenuse of the second triangle. The hypotenuse of the second triangle is equal to 5x minus 19. Again, substitute the value of x, which is 7, into the equation. It will become 5 times quantity 7 minus 19. 5 times 7 is equal to 35. Then 35 minus 19 is equal to 16. So, the hypotenuse of the two right triangles are congruent. Did you get the correct answer? If yes, congratulations! And for your assignment, find the values of t and the measure of angle D. Based on the figures, we have here the right triangle ABC with angle C measuring 75 degrees and the right triangle DEF with angle D measuring 5t degrees. Side AB and side EF are congruent. Angle A and angle F are also congruent. Pass your answers to your respective math teacher. That's all for today's lesson. Once again, this is your teacher broadcaster, Sir Jason. Thank you and God bless.
That's great! Thank you, Sir Jason, and thank you, viewers and listeners, for tuning in. I hope you have learned something today. Once again, I am your teacher host, Teacher Joseph, saying, if math is hard and so is life, then get over it. Have a nice day. Bye-bye!